Hello dear students, in this video I'll continue with solving the sample paper for CBSE Class 12 Applied Mathematics for the session 2022-23. In my previous video I have solved the multiple choice questions from section A of the sample paper. In this video we will see the questions from section B and section C of the sample paper. Here we have section B. The questions in section B is of 2 marks. Here we have the instruction. All questions are compulsory. In case of internal choice, attempt any one question only. Now we'll move on to the questions from section B. 21st question. Rupees 2,50,000 cash is equivalent to a perpetuity of rupees 7,500 payable at the end of each quarter. What is the rate of interest convertible quarterly? So here the present value of perpetuity is given. This is the present value of perpetuity. It is 2,50,000 cash. Now this is the present value of this perpetuity. So this is the periodic payment. It is rupees 7,500 and it is payable at the end of each quarter. We need to find the rate of interest that is convertible quarterly. So let us take, let R be the rate of interest. Then it is given the present value of perpetuity is rupees 2,50,000 and then the periodic payment is rupees 7,500 and then the rate per period I is equal to R by 4 because here the rate of interest is compounded at the end of each. Here the rate of interest is compounded quarterly. So I is equal to R by 4. So we have the present value of perpetuity P is equal to R by I. If we substitute each of these values, we will be able to find the rate of interest R. So 2,50,000 equal to 7,500 upon R by 4. Or if we cross multiply, we get 2,50,000 into R by 4 equal to 7,500. It is. So from this we get R is equal to 75 by 625. So this will go in 25 3 times. This is 25 times. If you want to express it as percentage, it is into 100%. Therefore, R is equal to 12%. Therefore, rate of interest is equal to 12%. So writing what is given and the formula carries 1 mark. The remaining steps and the final answer carries 1 mark. So a total of 2 marks. Moving on to the next question. The next question is an either or type. It is enough if we attempt any one of these two. So let us see each one. Find the value of 2a plus 3b minus c if a equal to this matrix is a skew symmetric matrix. So here it is given A is a skew symmetric matrix. We need to find the value of 2a plus 3b minus c. So given A is a skew symmetric matrix. If A is a skew symmetric matrix, it means A transpose is equal to negative A. Now A transpose is the transpose of this matrix. So A transpose will be, the first row will become the first column, the second row becomes the second column, and the third row becomes the third column. It is equal to minus A. So it will be 0, minus of minus 1 is plus 1, then minus 28. Here we have minus of A minus 8, then 0 minus 3b. Then here we have c minus 2, then minus 2, 0. And now we can compare each and every element in these two matrices. So comparing Here A minus 8 is equal to 1. Every element in this matrix is equal to the corresponding element in this matrix. Only then we call the two matrices equal. So A minus 8 is equal to 1 implies A equal to 9, and then here we have minus 3B equal to 2 implies B equal to minus 2 by 3, and then here C minus 2 equal to 28, or 28 equal to C minus 2 implies C is equal to 30. So we got A, B and C. Now we can find 2A plus 3B minus C. 2A plus 3B minus C equal to 2 into 9 plus 3 into negative 2 by 3 minus 30. So this is 18 minus 2 minus 30. So this is minus 14. Therefore, 2A plus 3B minus C equal to negative 14. So here finding the value of A, B and C carries 1 mark, and finding the value of 2A plus 3B minus C equal to 14, it carries 1 mark. They are part of the same question. There are two real values of x for which the value of determinant delta equal to this determinant is 86. Find the values of x. So here we need to find the value of x, value or values of x for which the value of this determinant is 86. So given delta equal to 1 minus 2, 5, 2x minus 1, 0, 4, 2x equal to 86. Expanding along R1. Let us expand along the first row. We get delta is equal to 1 into 2x square plus 4 plus 2 into 4x minus 0 plus 5 into 8 minus 0. This is equal to 86. Or we get 2x square plus 4 plus 8x plus 40 equal to 86. That is 2x square plus 8x minus 42. This is equal to 0. So here 2 is common, we can take it outside. So it is 2 into x square plus 4x minus 21 equal to 0. Now this cannot be 0. So x square plus 4x minus 21 is 0. So here we can factorize this. It is x square plus 7x minus 3x minus 21 equal to 0. So it is x into x plus 7 minus 3 into x plus 7 equal to 0. Or we get x minus 3 into x plus 7 equal to 0. Or from this we get x is equal to 3 comma minus 7. So these are the two real values of x for which the value of this determinant is 86. Expanding along a particular row and writing this step carries 1 mark, and then finding the values of x carries 1 mark. Moving on to the next question. A book publisher sells a hardcover edition of a book for rupees 22 and a paperback edition for rupees 40. In addition to a fixed weekly cost of rupees 9,600, the cost of printing hardcover and paperback editions are rupees 56 and rupees 28 per book respectively. Each edition requires 5 minutes on printing machine, whereas hardcover binding takes 10 minutes and paperback takes 2 minutes on the binding machine. The printing machine and the binding machine are available for 8 hours each week. Formulate the linear programming problem to maximize the publisher's profit. So here we can see that a book publisher sells two types of editions. One is hardcover and the other one is paperback. He sells it for rupees 72 and rupees 40 respectively. And then the fixed cost is rupees 9,600 and the cost of printing hardcover is rupees 56 and paperback is rupees 28 per book. And regarding the availability of machine, it is given each edition requires 5 minutes on printing machine, whereas hardcover binding takes 10 minutes and this paperback takes 2 minutes on binding machine. Each machine is available for 80 hours each week. We need to formulate this linear programming problem to maximize the publisher's profit. So first we have to write the objective function. So let the number of hard copy and paperback copies be X and Y respectively. So we have taken hardcover edition as X and paperback edition as Y. So we have to maximize the profit. Profit is given by revenue minus cost. So here it says he sells hardcover edition for rupees 72 per book. So the revenue for X hard copy books will be 72X and for Y paperback books will be 40 plus 40Y. And then the fixed cost is 9,600. So minus 9,600 minus the cost of printing hardcover, it is rupees 56 per book. So 56X minus the cost of printing paperback edition is 28 per book. So it is 28Y. So this, when we simplify, we will get the profit. So it is 16X plus 12Y minus 9,600. So the objective function is maximize profit. Z is equal to 72X plus 40Y minus 56X minus 28Y minus 9,600, or it is equal to 16X plus 12Y minus 9,600. So this is the objective function. And now we have the constraints. Here it is given each edition requires 5 minutes on printing machine. So hard copy requires, this is in minutes. Hard copy requires 5 minutes and paperback copy also requires 5 minutes on printing machine. And then for binding, this is also in minutes. For binding, hardcover binding takes, it is given 10 minutes and paperback takes 2 minutes. And then it is given printing machine and binding machine are available for 80 hours each week. So here availability of printing machine is 80 into 60 because here we have in minutes. So it is 4,800 minutes and binding it is again 80 hours or 80 into 60 minutes, which is 4,800 minutes. This is also in minutes. So subject to the constraints, 5x plus 5y less than or equal to 4,800. Now this, when we simplify, it is, when we divide by 5 we get x plus y less than or equal to 960. And next we have the constraint with respect to binding. It is 10x plus 2y less than or equal to 4,800, or when we divide by 2 we get 5x plus y less than or equal to 2,400. And the non-negative constraints x comma y greater than or equal to 0. So this is the first constraint and this is the second constraint. All these are rough. I have written only for your understanding. So writing the objective function, this step carries 1 mark, and writing the constraints, subject to the constraints, writing these inequalities carry 1 mark. Next question. A boatman takes half as much time in rowing his boat for a certain distance downstream than upstream. What is the ratio between his speed of rowing the boat in still water and speed of current? So here we can see that a boatman takes half the time of rowing downstream than the same distance upstream. We need to find the ratio between speed of the boat in still water and speed of the current. So let us take speed of the boat in still water is x, the usual notation that we use. Speed of the stream is y km per hour and distance travelled is d kilometer. Now the time taken to travel downstream will be distance by downstream speed. So distance is d and the downstream speed will be x plus y. Then time taken to travel upstream will be distance by upstream speed. It is upstream speed is x minus y. Now it is given the time taken to go downstream, that is d by x plus y. It is half the time taken to go upstream. So it is half of d by x minus y. From this we need to find the ratio of speed of the boat in still water to speed of current. So here d and d will get cancelled. Here we get 2x minus 2y equal to x plus y, or x is equal to 3y, x by y equal to 3 by 1. Therefore, x is to y equal to 3 is to 1. So the ratio of speed of boat in still water to speed of current is 3 is to 1. So here writing all these steps carries 1 mark, and then using the condition given and finding the final answer carries 1 mark. This is the OR part of the same question. In a 200-meter race, Anush can beat Param by 5 meters or 3 seconds. How much time did Anush take to complete the race? So here it is given Anush can beat Param by 5 meters or 3 seconds. So from this we can find the speed of Param. It means Param travels 5 meters in 3 seconds. So speed of Param is distance by time. So it is 5 by 3 meters per second. Now time taken by Param to complete the 200-meter race. It will be distance by speed. So it is 200 upon speed of Param, 5 by 3. So this is 120 seconds. So here time taken by Param to complete the 200-meter race is 120 seconds. Here it is given Anush can beat Param by 3 seconds. So time taken by Anush to complete the race, it will be 120 minus 3. So it is 117 seconds. So finding the time taken by Param to complete the race carries 1 mark, and finding the answer carries 1 mark. Moving on to the next question. Mithul invested rupees 3,50,000 in a fund. At the end of the year, the value of the fund is rupees 4,37,500. What is the nominal rate of interest if the market price is same at the end of the year? Here we need to find the nominal rate of interest. The initial value of the fund and the final value of the fund is given. So this is very easy. Given initial value of the fund is rupees 3,50,000. Then final value is rupees 4,37,500. Nominal rate. We know the formula. It is final value minus initial value upon initial value into 100. So this is 4,37,500 minus 3,50,000 divided by 3,50,000 into 100. So this is 87,500 upon 3,50,000 into 100. So this is equal to 25%. Therefore, nominal rate is equal to 25%. Here writing what is given and the formula carries 1 mark. Calculation and final answer carries 1 mark. Now moving on to the next section, section C. Find the 26th question. The instruction is all questions are compulsory. In case of internal choice, attempt any one question only. 26th question. Find the interval or intervals in which the function f of x equal to x raised to 4 by 4 minus 2x cube plus 11x square by 2 minus 6x is strictly increasing and strictly decreasing. So we need to find the intervals in which this function is strictly increasing and strictly decreasing. First we have to find the critical points by equating f dash of x equal to 0, and then using that we can find the values of x, we can find the intervals, and then we can find the intervals in which this function is strictly increasing and strictly decreasing based on the sign of f dash of x. So here given f of x is equal to x raised to 4 by 4 minus 2x cube plus 11x square by 2 minus 6x. At the critical points, f dash of x equal to 0 implies f dash of x equal to 4x cube by 4 minus 6x square plus 11 into 2x by 2 minus 6. This is equal to 0. Or here x cube minus 6x square plus 11x minus 6 equal to 0. Now if we substitute x as 1 and c, by seeing here itself it is clear that 1 minus 6 plus 11 minus 6, it is 0. So for x equal to 1, f dash of 1 is 1 minus 6 plus 11 minus 6 equal to 0. So the meaning is that x minus 1 is a factor. So f dash of x is equal to x minus 1 into, we have to divide this by x minus 1 to find the other factor. Now we can divide this cubic equation using synthetic division. So first let us write the coefficients of each of these. Coefficient of x cube is 1, x square is minus 6, x is 11, and constant term is minus 6. And here we have the factor as x minus 1. So here let us write 1. Bring this 1 here. Then 1 into 1 is 1. Now we have to add these two. Minus 6 plus 1 is minus 5. Then 1 into minus 5 is minus 5. Here 11 minus 5 is 6. Then 1 into 6 is 6. So here we have 0. So this is basically synthetic division. Here this represents coefficient of x square, this represents coefficient of x, and this is the constant term here. And if it is 0 here, it means when we divide this expression by x minus 1, the remainder is 0. This is the remainder that we get here. So it is x minus 1 into x square minus 5x plus 6. X square minus 5x plus 6. Now we know how to factorize this. Here 6 is 2 into 3. So it is x minus 1 into x minus 2 into x minus 3 equal to 0, implies x is equal to 1, 2, 1, 3. So the various critical points are 1, 2, 1, 3. And now we have found the values of x for which f dash of x is equal to 0. So for the values x equal to 1, 2 and 3, f dash of x is 0. So let us mark these points on a number line. We have 1, 2 and 3. And now let us see the intervals in which f dash of x is, it is positive or negative. If f dash of x is positive, it means the function is strictly increasing on that interval. If it is negative, then it is strictly decreasing on that interval. Now if we consider the interval from 3 to infinity, if we substitute any value, say 4 in this interval and check, f dash of x is positive. If we consider the interval 2 to 3, if we substitute a point, say 2.5 in this f dash of x, here we can see that f dash of x is negative. Then in the interval 1 to 2, it is positive. In the interval minus infinity to 1, it is negative. So let us draw a table like this. We have the interval, open interval minus infinity comma 1, then 1 comma 2, then 2 comma 3 and 3 comma infinity. In this interval minus infinity to 1, the sign of f dash of x is negative. In the interval 1 to 2, it is positive, or f dash of x is less than 0 in this interval. F dash of x less than 0. In this interval 1 to 2, f dash of x is more than 0. In the interval 2 to 3, f dash of x is again less than 0. In the interval 3 to infinity, f dash of x is more than 0. It is positive. So in this interval, since f dash of x is less than 0, f is decreasing. So the nature of function f is, it is decreasing on this interval. And in this interval, open interval 1 comma 2, since it is positive, f is increasing. And in the interval 2 comma 3, f dash of x is less than 0. So here again f is decreasing. And finally in the interval 3 comma infinity, f dash of x is positive. So f is increasing on this interval. So we can write the result. F is strictly increasing in open interval 1 comma 2 union 3 comma infinity in these two intervals. And f is strictly decreasing in open interval minus infinity comma 1 union 2 comma 3. So in these two intervals, it is strictly decreasing. So here finding the value of x carries 1 mark. Then finding the interval in which f is strictly increasing carries 1 mark. Finding the intervals in which f is strictly decreasing carries 1 mark. The same question it is given in the CBSE Handbook. It is on page number 3A25. It is given in the CBSE Handbook. Moving on to the next question, we have 27th question. Two badminton teams A and B are staying in the same hotel. Team A has 2 male and 3 female players accompanied by 1 coach. Team B comprises of 1 male, 2 female players and 2 coaches. The daily diet requirement, calories and protein for each person is as given below. So we have the calories and protein required by each player, male, female and the coach. Use matrix algebra to calculate the total diet requirement of calories and protein for each team. Similar questions are given in the CBSE Handbook, in exercise also, in examples also. So here we need to find the total diet requirement of calories and protein for team A and team B using matrix algebra. So this is very easy. Daily diet of team A, it is given by team A has 2 male, 3 female and 1 coach. So 2, 3, 1, this matrix into this matrix. That is the matrix for the daily diet requirement, calories and protein, into 2500, 1900, 2000 and 65, 50 and 54. After performing matrix multiplication, we will be able to get the total diet requirement for each team. So this is with respect to calories and this is with respect to protein. Now let us multiply these two matrices. This is equal to first row, first column. So it is 2 into 2500 plus 3 into 1900 plus 1 into 2000. And then here we have 2 into 65 plus 3 into 150 plus 1 into 54. So this is 5000 plus 5700 plus 2000. And here we have 130 plus 150 plus 54. It is ordinary matrix multiplication that has to be performed to find the answer. So when we add all these, we get this as 12,700 and here it is 334. So this is the amount of calories required and this is the amount of protein required. So team A consumes 12,700 calories and 334 grams of protein. Now moving on to the daily diet of team B. Daily diet of team B. Team B comprises of 1 male, 2 female players and 2 coaches. So we have the matrix 1, the row matrix 1, 2, 2 and then we have the matrix for the diet requirement. 2500, 1900, 2000, 65, 50, 54. Again we have to multiply these two to get the answer. So this is 2500 plus 1 into 2500 plus 2 into 1900, 3800 plus 2 into 2000, 4000. Here 1 into 65, 65 plus 2 into 50, 100 plus 2 into 54, 108. When we add all these, the first row is 10,300 and the second row is 273. So team B consumes 10,300 calories and 273 grams of protein. So finding the total requirement for team A, this part carries 1.5 marks, and finding the total diet requirement for team B, this part carries 1.5 marks. Next question. Evaluate integral dx upon 1 plus e raised to x into 1 plus e raised to minus x. So here let us take, let I is equal to integral dx upon 1 plus e raised to x into this 1 plus e raised to minus x, let me write it as 1 plus 1 by e raised to x. So this is integral dx upon 1 plus e raised to x into e raised to x plus 1 upon e raised to x. So here if we take the reciprocal, we get e raised to x dx upon, here we have 1 plus e raised to x into 1 plus e raised to x. So it is 1 plus e raised to x the whole square. So the integral reduces to this form. Now this is very easy. We know how to find the integral of this function. We can use integration by substitution. Put 1 plus e raised to x as t, so that we get e raised to x dx equal to dt. So the given integral becomes integral, in place of e raised to x dx we can put dt, and in place of 1 plus e raised to x we can put t. So it is integral dt by t square, or it is integral t raised to minus 2 dt. Now we know what is integral x raised to n dx. It is x raised to n plus 1 upon n plus 1 plus c. So I will be t raised to minus 2 plus 1 upon minus 2 plus 1 plus c, or it is minus 1 by t. This is t raised to minus 1 by minus 1. So it is minus 1 by t. Now we can substitute for t again. We have taken t as 1 plus e raised to x. That we can substitute here. Therefore, I is equal to minus 1 by 1 plus e raised to x. So this question carries 3 marks. Plus c. I forgot this constant of integration. This is very important. Plus c. And next we have the R part of the same question. Evaluate integral x into log of 1 plus x square dx. So first let us write, let I equal to the given integral x into log of 1 plus x square dx. Now let us use integration by parts. Integrating by parts. When we are using integration by parts, we have to remember the order in which we have to take the first function and the second function, isolate, where I stands for inverse trigonometric function, L for logarithmic, A for algebraic, T for trigonometric, and E for exponential function. So we have to take logarithmic function as the first function and algebraic function as the second function. So using integration by parts, we get I is equal to log of 1 plus x square integral x dx minus integral derivative of the first function, derivative of log of 1 plus x square into integral x dx into dx. So this is equal to log of 1 plus x square into x square by 2 minus integral derivative of log of 1 plus x square is, we have to use chain rule of differentiation to differentiate this. First we have to consider this as a single function. So log of that single function will be 1 by 1 plus x square, and then we have to differentiate this 1 plus x square into 2x into, here integral x dx is x square by 2 dx. So this 2 and this 2 will get cancelled. This is equal to x square by 2 into log of 1 plus x square minus integral x cube upon 1 plus x square dx. Here if we add and subtract x, we will be able to integrate. So let us add and subtract x. So the given integral becomes x square by 2 log of 1 plus x square minus integral, I am considering the first two terms alone, x cube plus x. So we can take x outside from that. So it is x into x square plus 1 minus x upon 1 plus x square dx. So here this we can write it as x into x square plus 1 upon x square plus 1 minus x upon x square plus 1. So this is x square by 2 log of 1 plus x square minus integral x minus x by 1 plus x square dx. Now we can integrate x dx, and for this we can use integration by substitution to integrate this function. If we are familiar with how to integrate it, we can integrate it directly. Otherwise, we can use integration by substitution for this part alone. So let us put 1 plus x square equal to t, so that x dx will be dt by 2. So the given integral becomes x square by 2 log of 1 plus x square minus x square by 2. Here it is plus place of x dx we have dt by 2, so it is half integral dt by t. So this is x square by 2 into log of 1 plus x square minus x square by 2 plus half log mod t plus c. Now we can substitute for this t. T we have taken as 1 plus x square. Here half is common, let us take it outside. So this is equal to half of x square log of 1 plus x square minus x square plus, in place of t we can put 1 plus x square. Since 1 plus x square is a positive term, we can write it as 1 plus x square plus c. So here this log of 1 plus x square is common. So the given integral is half of x square plus 1 log of 1 plus x square minus x square plus c. So this is the integral of this function. Moving on to the next question. Under the pure market competition scenario, the demand function PD and the supply function PF for a certain commodity are given as PD equal to 8 by x plus 1 minus 2 and PS is equal to x plus 2 by 3 respectively, where P is the price and X is the quantity of the commodity. Using integrals, find the producer surplus. So here it is given, the demand function and the supply function is given under pure market competition scenario. Under pure market competition, at equilibrium, the quantity demanded is equal to the quantity supplied. So using that, we can find the equilibrium quantity and then the equilibrium price, and then we can find the producer surplus. Under pure competition, pure market competition, PD equal to PS. This implies 8 by x plus 1 minus 2 equal to x plus 3 by 2. Let us take LCM and simplify. 8 minus 2x minus 2 upon x plus 1 equal to x plus 3 by 2, or it is 2 into 6 minus 2x equal to x plus 1 into x plus 3. So we get 12 minus 4x equal to x square plus 4x plus 3. When we transpose this 12 minus 4x to the other side, we get x square plus 4x plus 3 plus 4x minus 12 equal to 0, or x square plus 8x minus 9 equal to 0. Now this is a quadratic equation in x. So we can factorize this. When we factorize, we get x plus 9 into x minus 1 equal to 0. From this we get x is equal to 1 comma x is equal to minus 9. Now the quantity, it cannot be negative. So this is not possible. So x is 1. Therefore x is equal to 1. Therefore x equal to 1. Now let us find the equilibrium price. When x not equal to 1, we can substitute either in a demand function or supply function. Wherever we substitute, we'll get the same answer. I'm substituting here P naught equal to 1 plus 3 by 2. It is 4 by 2, which is 2. So when x naught equal to 1, P naught equal to 2. Now we can find the producer surplus. Therefore producer surplus, it is equal to P naught x naught minus integral 0 to x naught supply function dx. So P naught x naught is 2 into 1, which is 2, minus integral 0 to 1. Supply function is x plus 3 by 2 dx. So it is 2 minus half into x dx is x square by 2 plus 3 dx is 3x with the limits 0 to 1. So it is 2 minus half into half plus 3 minus 0. It is 2 minus half into 7 by 2. Now this is 2 minus 7 by 4. It is 8 minus 7 by 4, 1 by 4. Therefore, producer surplus equal to 1 by 4. So here finding the value of x, that is the equilibrium quantity, it carries 1.5 marks. This part carries 1.5 marks, and then finding the producer surplus. This part carries 1.5 marks. The R part of the same question, it is given the demand function P for maximizing a profit monopolist is given by P equal to 274 minus x square, while the marginal cost is 4 plus 3x for x units of the commodity. Using integrals, find the consumer surplus. So here the demand function is given, and here the economy is it is a profit monopolist economy. The demand function is given by 274 minus x square, and the marginal cost is given. We need to find the consumer surplus. So given demand function is P equal to 274 minus x square. Then the revenue function R of x is given by P into x. So it is 274x minus x cube. From this we can find the marginal revenue. Marginal revenue is derivative of revenue function. So it is 274 minus 3x square. And then the marginal cost is given. Marginal cost is 4 plus 3x. It is given here. In a profit monopolist market, we have marginal revenue equal to marginal cost. So marginal revenue equal to marginal cost implies 274 minus 3x square equal to 4 plus 3x. Or let us transpose to one side. 3x square plus 3x plus 4 minus 274 equal to 0, or 3x square plus 3x minus 270 equal to 0. If we divide the entire equation by 3, we get x square plus x minus 90 equal to 0. Now this is a quadratic equation in x. So we can find the value of x. So here the factors are, it is 10 and minus 9. So it is x plus 10 into x minus 9 equal to 0. This implies x is equal to 9 or x equal to minus 10. Getting a negative quantity is not possible. Therefore, x is equal to 9. So this is the equilibrium quantity. Now we can find the equilibrium price from the demand function. When x naught equal to 9, p naught equal to 274 minus 81. We can substitute here in the demand function to find the equilibrium price. So this is equal to 193. P naught equal to 193. Now we have to find the consumer surplus. The consumer surplus, it is given by integral 0 to x naught demand function minus P naught x naught. So it is integral 0 to x naught is 9. Demand function is 274 minus x square dx minus 193 into 9. So this is 274x minus x cube by 3 with the limits 0 to 9 minus 1737. Now this, when we substitute the upper limit, we get 2466 minus 9 cube into 9. So it is 9 cube by 3. It is 243 minus 1737. Now this, when we simplify, it is 486. Therefore, the consumer surplus is 486 units. Again here, up to finding the value of x, writing all these steps up to finding the value of x carries 1.5 marks, and then finding the consumer surplus, remaining steps and finding the consumer surplus carries 1.5 marks. Next question. Surjit purchased a new house costing rupees 40 lakhs and made a certain amount of down payment so that he can pay the balance by taking a home loan from XYZ bank. If his equated monthly installment is rupees 30,000 at 9% interest compounded monthly, here they have given reducing balance method and payable for 25 years, then what is the initial down payment made by him? So here we can see that Surjit has purchased a house costing rupees 40 lakhs and made a certain amount of down payment. That is what we have to find. And the balance he has paid by taking a home loan. So here we can see that Surjit purchased a new house whose cost is rupees 40 lakhs and has made certain amount of down payment. That is what we have to find. The remaining amount, he has taken EMI from the bank. His EMI is rupees 30,000 and interest is 9% compounded monthly and payable for 25 years. We need to find the initial down payment which is made by him. So here this is using EMI formula, we have to find the initial down payment. So let us take, let the down payment be X. And then the purchase price is given, it is rupees 40 lakhs. So the balance, that is the balance for which loan has been taken or the amortized amount, it is nothing but 40 lakhs minus X. And then we have the interest. Interest I is 9% compounded monthly. So it is 9% by 12, or it is 0.09 by 12. It is 0.0075. So this much is the interest compounded monthly. Next we have N, number of conversion periods. It is 25 into 12. 25 into 12. Since EMI is paid monthly for 25 years, N will be 25 into 12. It is 300. And then the equated monthly installment it is given. It is rupees 30,000. Rupees 30,000. Here we know the formula for EMI. Using that formula, we can find the value of X. We have EMI R is equal to A into I upon 1 minus 1 plus I the whole raised to minus N. R is 30,000. A is 40 lakhs minus X. I is 0.0075 upon 1 minus 1 plus 0.0075 the whole raised to minus 300. So it is 40 lakhs minus X into 0.0075 upon 1 minus, this is 1.0075 the whole raised to minus 300. The value is given here. It is 0.1062. 40 lakhs minus X into 0.0075 upon 0.8938. So from this we get 40 lakhs minus X is equal to 30,000 into 0.8938 upon 0.0075. Now this, when we multiply 30,000 into 0.0078, it comes out to be 8,938 into 3. It is 26,814 upon 0.0075. Now this, when we simplify, it is 35,75,200. So 40 lakhs minus X is this much amount. So X will be the difference between 40 lakhs and 35,75,200. This, when we subtract, we get 4,24,800. So the down payment is rupees 4,24,800. This is the down payment. So writing what is given, it carries 1 mark. Then substituting the values and finding the final answer carries 2 marks. Next question. 10 years ago, Mr. Mehra set up a sinking fund to save for his daughter's higher studies. At the end of 10 years, he has received an amount of rupees 10,21,760. What amount did he put in the sinking fund at the end of every 6 months for the tenure, which paid him 5% per annum, compounded semi-annually? So here it is given 10 years ago. So the time period is 10 years. 10 years ago, a sinking fund was set up, and at the end of 10 years, the amount received is rupees 10,21,760. We need to find the amount that was put in the sinking fund at the end of every 6 months, which paid him 5% per annum, compounded semi-annually. So this is sinking fund problem. Let us take, let amount put in the sinking fund at the end of every 6 months be R. And then amount accumulated in the sinking fund A, it is given here. It is rupees 10,21,760. Interest is 5% per annum compounded semi-annually. So it is 5% divided by 2, 0.05 by 2. It is 0.025. And then N is, it is put at the end of every 6 months. The time period is 10 years. So N will be, number of conversion periods will be 10 into 2, which is 20. And now we know the sinking fund formula. That formula we can use and we can find the answer for R. We know A is equal to R into 1 plus I the whole raised to N minus 1 upon I. This implies A is here 10,21,760 equal to R is what we have to find. R into 1 plus I is 0.025 the whole raised to N is 20 minus 1 upon 0.025. Now when we cross multiply this 10,21,760 into 0.025, it comes out to be 25,544. This is equal to R into, here 1 plus 0.025 is 1.025, the whole raised to 20 is 1.6386 into 1.6386 minus 1. This is R into 0.6386. So from this we get R is equal to 25,544 divided by 0.6386. Now this, if we try to remove the decimal point and if we divide 25,544,00,00 divided by 6386. So here if we consider 25, 6 4s are 25. So let us try 4. So the answer is 40,000. So it is 40,000. Therefore, R is equal to rupees 40,000. So Mr. Mehra set aside an amount of rupees 40,000 at the end of every 6 months. So here writing what is given and writing the formula carries 1.5 marks. Then substituting the values, doing the calculation and writing the final answer carries 1.5 marks. I hope this video was useful for you. In this video we have solved the questions from section B and section C of the sample paper. In my next video I will complete with sample paper where I will solve the questions from section D and section E. If you have not subscribed to my channel, please subscribe. Thank you for watching.